Today, we're going over surface tension. Surface tension is the ability of things denser than water to sit on top of water. To show this, we will use this piece of graphite from a lead pencil. This graphite's dimensions are 0.74 millimeters in diameter and 60.4 millimeters in width. If we place this piece of graphite onto the water, we see that it floats instead of sinks, even though its density is more than water. This is because of surface tension. Surface tension is caused by the molecules being attracted to each other and not allowing that piece of lead or piece of graphite to go through those molecules and sink towards the bottom. That force between those molecules is keeping that graphite up. If we lightly tap on that piece of graphite, you can see that it immediately sinks to the bottom because it's a denser material, and we've let it through those first molecules, allowing it to sink and breaking that surface tension. We can add things like surfactants into the water to break that surface tension and allow it to sink immediately. A common surfactant is dish soap. If we add a little bit of dish soap into our water, you will see that the graphite will not sit on top and it will just directly sink right to the bottom. I'm adding enough surfactant to make sure that the lead will sink directly to the bottom. We stir until it is completely placed in the water and there's no big chunks or big clumps of dish soap in this solution. Once you're satisfied with how much it is distributed throughout the water, you can stop stirring and let it sit down. We will dry off the lead to give it the best chance of float on top of the surfactant and water mixture. I will drop this piece of graphite onto the water gently, and you see that it sinks immediately. It has no chance of floating. This is because the strong forces between those water molecules have been broken. They're no longer attracted to each other as much as they once were, because there are surfactants in between them, breaking up and making those distances between those molecules greater. A common use for surface tension is camping equipment. Camping equipment uses nylon. Nylon is braided so tightly that the water molecules will bead up instead of go through the material. If I pour this water onto the material, you see that it beads instead of goes through. Now if I pour on the solution of water, you'll see that it changed color immediately, showing that this has gone through the material. This is also one reason why when you're camping, they say never to hit the tarp or never to hit your tent, because it's only semi-impervious to this water. If you tap enough, this water will go through and end your camping trip and make you really kind of wet and kind of make it a terrible situation for everyone. This is how surface tension works. Thank you.